All right, welcome to number one on the 8th grade air test review questions. Number one is giving us four tables to look at. We have these tables or sets of data with x, y coordinates in each. And it's asking us which of these tables represents a nonlinear function. And just to show what nonlinear means, if we have a linear function, simply put, it is a straight line. So that's a linear function. A nonlinear function would have a line that maybe curves up like this and does not stay constant. So that's a nonlinear function. We might also have a graph of a parabola, maybe, and that would be a nonlinear function as well. So what we're looking for is something that would create a graph like this, or in other words, something that's not a straight line. Now, put simply, a nonlinear function, or a function that is not a straight line, would have a changing slope. Its slope would not be a constant rate. So remember that slope and rate are the same. And we find our slope, if you recall, by using the formula y2 minus y1, or the change in y, over x2 minus x1, or the change in x. So that's what we're going to be using in these four tables to see whether or not the slope is constant or if it changes. If it does change, it's not constant, it's not a straight line. So in our first table here, we have the y coordinates of 3, 5, 8, and 14. Now, we can go through each one to make sure that they are constant or not, but really if we just go through a couple of them, we will see pretty quickly if it does remain constant. So I'm going to use y coordinates of 3 and 5. Our second one is 5, so that's going to be our y2, and our first one is 3, so that's going to be our y3. Likewise, x2 is going to be 1, and x1 is going to be a negative 1. So using this formula, y2 is going to be 5, y1 is going to be 3, so 5 minus 3. And our x2 is 1, and our x1 is a negative 1. So I'm going to say minus a negative 1. Now, 5 minus 3 is easy. That gives us 2. 1 minus a negative 1. There's our double negative. A negative times a negative gives it a positive. So this is going to be like saying 1 plus 1. So this is going to be 2 over 2, which gives us a slope of 1. That's our rate in that one. Now let's see if it's constant. So we're going to do another set. Since I used 3 and 5, now I can use 5 and 8. 8 is going to be our new y2, so I'm going to say 8 minus 5, that's our new y1. And then our x2 is going to be 4, and our x1 is going to be 1. So it's going to be 4 minus 1. Now 8 minus 5 gives us 3. And 4 minus 1 also gives us 3, which is going to be a slope or a rate of 1. And now we can see, since our rate is the same in here, if you want to go ahead and do 14 minus 8 and check that, I promise you it will come out again as a slope of 1. So this table is good. It is a straight line. It is a linear function, so we don't have to circle that one. It is not nonlinear. Now let's go on to the second table. Let's see if that one is nonlinear or not. Our second table gives us negative 3, negative 9 for our first two y coordinates. So y2 is a negative 9, and y1 is a negative 3. So there's a minus a negative 3. And that's going to bring us to our x coordinates of 5 and 2. 5 is our x2, and 2 is our x1. So we're going to subtract this. Negative 9 minus a negative 3. That's going to be like saying 9 plus 3. But we have that negative sign here, so let's not forget that right away. That's going to give us a negative 6 over 5 minus 2 is 3. So now that's going to reduce to a negative 2. And we're going to see if this is going to stay constant in our table here. So let's see if we continue with a negative 2. Let's go on to a y2 of negative 13 and a y1 of negative 9. And we can draw that line. We have our x2 is 7 and our x1 is 5. So we're going to say 7 minus 5, and that If we say, oh, I almost forgot something. That's minus a negative 9. Sorry about that. So if we say 13 plus 9, there's our double negative there. We're going to be using this negative sign, negative 13 plus 9. Treat it like a subtraction with that negative sign remaining in the larger number. And that's going to give us a 4, a negative 4. And 7 minus 5, of course, will give us 2. A negative 4 over 2 is going to give us a negative 2. So these do correspond. Our slope does stay the same. And if we continue to calculate with this pair, we would see that it is still negative 2. So this table is linear. It is not going to be one of our answers. Now here's a little test-taking tip, by the way. Notice that in the directions it says circle the table that is nonlinear. That's suggesting that there's only one table in here that is nonlinear. So we're going to see if it's the third table or the fourth table right now. But if we find out that it's the third table, we probably don't have to do the math for the fourth one. However, as a test-taking tip, always check. Make sure you do every step. Even though it says circle the table, suggesting there's only one, just make sure and double check on both of them. So let's do table number 3 here. Our y2 is going to be 12 and our y1 is going to be 0, so that's easy. We're going to use 12 minus 0 as our first part. All right, so 12 minus 0, that's y2 minus y1. And then, of course, we have x2 is 4 minus 0. That's 4 minus 0. Now that's going to give us a final of 12 over 4, which of course comes out to 3. Now, that's our first set. And then if we go to our second set, we have a y2 of 18 and a y1 of 6. So let's say 18, and I'm sorry, an x2 of 6. So we're going to say y2 minus y1, 18 minus 12 over 6 minus 4. That will give us 6 over 2. And of course, that comes out also to 3. So it looks like our third table is going to remain constant as well. We have a rate of 3 as our slope, so that one is good. So we can probably assume we have already found it. It's going to be table number 4, which is non-linear. But like I said, test-taking tip, always double check. So let's see what we get here with our last table. We have a y2 of 17. Let's see if I can get my chalk to stay the same size here. I don't know why it keeps on changing on me. We have a y2 of 17 and a y1 of 5. So it's going to be 17 minus 5 over an x2 of 4 and an x1 of 2. So now 17 minus 5 will give us 12. And 4 minus 2, of course, will give us 2, and that gives us a slope of 6, or a rate of 6. So let's see if we keep the same rate by using our next coordinates, 65 for our y2 and 17 for our y1. So of course, if we do 65 over 17, y2 minus y1, and then we have our x coordinates, 8 minus 4, 65 minus 17 is going to give us a 48, and 8 minus 4 is going to give us 4. Now, we can probably already tell this is not going to be 6. So 48 divided by 4, of course, is going to give us 12. And that is not the same, not constant. So this is actually going to cause a graph to do something like this. It's going to make the line go curved and non-linear. So of course that is our answer right there. Table number 4 is the non-linear table. Circle that, and let's go on to number 2.